Hello, back again for presentation number 4. I have decided to do the presentation over the Permian extinction, so that event in history. So I'll just jump right into it. The Permian extinction is still very much debated about today, about the causes of it, why it happened, um, and why would scientists be so concerned with it? Well, Permian extinction was extremely significant. Of the 5 or so mass extinctions that occurred on Earth, the Permian extinction was the most significant. The most things died during the Permian extinction. And so, scientists have really been trying to figure out why that happened. Why did 90% of all life on Earth itself die? Why did there was only, I think, less than 5% of remaining marine life, and over 2/3 of land animals wiped out, almost all trees and vegetation also wiped out. So scientists have really been thinking, how did this happen? So we've been looking back in time 250 million years, basically. Permian extinction believed to happen 250 million years ago, the beginning of the Triassic, the end of the Permian, of course. And so, what are some of the theories that they have? Well, I guess just kind of a basic overview of the time. Continentally, we know that during the time of the Permian extinction, Pangaea had just come together. So this was major. The supercontinent forming. This it doesn't happen very often. So what occurs when supercontinents come together? Well, this enormous supercontinent Pangaea existing, and it has a huge ocean around it. We know along the edges of Pangaea, like coastal regions, is very shallow. Fossil evidence shows the type of life, living along the coasts of Pangaea. It had to be shallow water bearing and that sort of thing. So, what does this mean? Why was there a big change when the supercontinent formed? Well, when you have a supercontinent form like that, you have significant changes in ocean circulation, and in this particular case, most scientists believe it's the lack thereof ocean circulation that caused the most problems. So you think, well, I have all this vegetation and oxygen, being this vegetation producing oxygen on the supercontinent, as well as algae and that kind of thing, producing it on the coastal regions. So if you don't have circulation, well, any oxygen that dissolves in the water is going to dissolve, along those coastal regions. So if you have no circulation, there's no way for the oxygen to get to the rest of the ocean, or even out far in the ocean at all. So this extremely problematic. Like I said before, over 95% of marine life wiped out. Well, major indicator of that was probably they didn't have enough oxygen. Also, with the CO2 cycle, with how that works, since there's not enough oxygen, there's probably an abundance of carbon dioxide. And we'll go in talking about the CO2 cycle. It's very important. But so huge CO2 spikes, and we know this through sedimentary evidence as well, of the fossils taken from the time period. We know there's large amounts of CO2 in the ocean, which is virtually toxic to a lot of the marine life of the time. So that's how so much of the marine life got wiped out. And we'll go into why there was such high CO2 levels and that kind of thing. But also, and I'll talk about this actually quite a bit, geologic evidence pointing towards major volcanic activity occurring in what is now present-day Siberia. So this major volcanic activity was said to last 1 million years, and lava covered over 1 million square miles. So this is just unheard of in anything present recorded history. Never had volcanic eruptions like that lasting millions of years. So you got to think, well, the volcanoes are putting huge amounts of heat into the atmosphere, CO2, sulfur dioxide, those greenhouse gas type things. And so that really leads to the conclusion that this this extinction was caused by a major change in climate and atmosphere, and conclusive evidence for an enormous temperature change can be found, from the fossils themselves. Scientists looking at the fossils, two abundant sediments from fossils of the Permian time would be, the elements in them would be calcium and magnesium. And they use these ratios of calcium, magnesium versus temperature. And scientists, can make kind of these, they're artificial fossils to provide a calibration curve of the ratio of carbon to magnesium versus temperature. And so we can analyze the fossils from the time because there's an abundance of fossils from this Permian extinction. Like I said, everything was dying so much it was settling into the sediment. Tons of fossils from the time, not so many fossils after the time. In the early Triassic, there's hardly any fossils. These are extremely rare. And that itself is another indicator of, just how we know this extinction occurred. And so from that back to the calcium to magnesium ratios of the fossils, they were able to kind of get a time graph of how much the ocean was increasing by time. With carbon dating of the fossils, they can see like over what time period the temperatures increased, and they have every estimate shows an increase in temperature, especially of the ocean temperatures. That's where most of the fossils were from. So some estimates showed increases of 11 degrees Fahrenheit, from when this extinction started. 11 degrees Fahrenheit raise in temperature of the ocean is just catastrophically enormous. To put that in perspective, scientists today, would really be warning about a 1 or 2 degree temperature in ocean, caused by temperature increase in the oceans caused by, say, global warming or something. They say that would have catastrophically enormous effects on life here on Earth. Well, this is raised 11 degrees, so it's kind of easy to understand, like, really how an enormous extinction like this could happen. Enormous temperature increase. More conclusive evidence, showing of this extinction would be the disruption to the carbon cycle. And a little bit about the carbon cycle. You know the carbon cycle very well. The carbon cycle would be basically, kind of your carbon intaking organisms, such as, all sorts of microbial bacteria, that take in carbon with photosynthesis, other nutrients, and then output oxygen. And then animals such as humans, animals of the time, especially more often, were, they'd inhale the oxygen, exhale the CO2, which would then go back to the microbes, the plants, the algae, that kind of thing. And that's the carbon cycle. And so we know there was a major disruption to this carbon cycle. Basically, just we can see that from carbon isotopes. And well, carbon isotopes have long been a signifier of the rate of the carbon cycle. And so the carbon cycle depends on many things, how much life is present and that sort of thing. Well, we knew that the carbon cycle was decreasing in rate just because of this carbon isotope ratio of the time. And, they can get the carbon isotope ratio from all sorts of fossils and that kind of thing from the time. So basically, the carbon cycle being disrupted just we can see there's a huge increase in CO2 levels from that evidence. And now I'll go into really what I think from all of what I read really caused this extinction. And many other people really agree with this as well. It's a combination of volcanic activity along with Pangaea, but I'd say primarily, formation of Pangaea, but I'd say primarily volcanic activity and these methane archaea, so these methane producing microbes, which really, like microbes, like microscopic things, like how could they cause such an enormous extinction? How could they cause such significant changes in excuse me. CO2 levels and temperature in general. Well, these methane producing microbes, we're able to study them today. They exist everywhere. They're in sewers, fecal matter for one, inside of stomachs of animals. So we're able to study these methane producing microbes. And basically, it was a competition back in the Permian era, between the methane producing microbes and the regular carbon cycle helping microbes in plants and that kind of thing. So what gave these methane producing microbes the upper hand? Well, we know at this time from sedimentary evidence there was huge deposits of organic sediment, and the main key ingredient in this organic sediment is acetate. And acetate is converted by the carbon cycle microbes into CO2, or they get CO2 from it and produce oxygen, while the methane microbes get the acetate from the organic sediment and produce methane. And so what we know today now is that these methane producing microbes are way more efficient, and so they were able to really just take hold, as along with the volcanic activity that was occurring, bringing so much nickel to the surface. The nickel is important because nickel is the only limiting nutrient to these microbes. So these microbes were basically had an unlimited food supply and no limiting nutrient because all this nickel was coming to the surface, to the oceans. So these microbes were really just allowed to bloom and boosting methane into the atmosphere, which then in turn, methane's a global warming, like greenhouse gas, in turn increase the temperatures, increase CO2 levels in the ocean, and really just brought about this enormous mass extinction. I think that's what happened to it. Along with that, the volcanic activity did some things on its own, so they really just catalyzed each other. The volcanic activity made the oceans more acidic, which caused major breakdowns among shelled animals, just because acidity breaks down calcium carbonate. That's what most of the shelled animals are made of. But I'm getting a little bit high on time here. Also contributing to the mass extinction, we know there was huge climate changes just because of glaciation patterns of the time. Glaciers forming at the poles of Pangaea, again just contributing to that ever-changing climate. So that's really what wiped everything out. The climate change, the methane producing microbes, the enormous amount of volcanic activity occurring in Siberia and China, and led to the greatest extinction ever to occur in Earth's history. So that's all the time I got. Thanks for listening.